I will show you. I will show you question 3. Where is it? It's here. Okay. All right. This is question 3, guys. Question number 3 is this one. So I'll give you about 5 minutes to see if you can do question 3. Hello guys, are you okay? Are you doing question 3 guys now? Hello. All right. Have you done question 3 yet or no? Not yet. Okay, good, good. All right. Let me show you. If you haven't done it yet, but let me show you how to do it. Share screen. Where it is? Okay. So this is question 3 on sheet number 10. So the question is, so you're given 2 random samples with from a population with mean, mu, and variance sigma squared, and you have an estimator for mu. So the estimator for mu is n times, excuse me, is n times x bar plus m times y bar divided by n plus m, right? And we want to show that this estimator is unbiased. So that's part 1, right? So I'm currently doing part 1 of question 3. So to show that something is unbiased, we need to show that the bias is 0, right? So the bias is the expectation minus the parameter that you're trying to estimate. So this is gonna be the expectation of n x bar plus m y bar divided by n plus m minus mu, right? So this is gonna be n n plus m times the expectation of 1 over n times the sum of xi plus m over n plus m times the expectation of 1 over m times the sum of yi minus mu. Okay. Now taking the expectation inside, you will get this, right? For the first term. For the second term, you will get right, and we know that the population mean is mu, so all the expectations are equal to mu. So it's going to be 1 over n plus m times the sum of mu and 1 over n plus m times the sum of mu minus mu. All right. Okay. And this is going to be n mu divided by n plus m, right? And this is clearly equal to 0. So what we have shown is that we have shown that mu hat is unbiased for mu. All right, guys, are you okay with this so far? You have any questions? All right. Yes. No. Okay. All right. Next one is I want to show. I also want to show that you have an estimator for sigma squared, which is given as n minus 1 times the sample variance for the x's plus m minus 1 times the sample variance for the y's divided by n plus m minus 2. All right. Now, using I'm sure you guys know the formulas for the sample variances. So using those, you can write this. You can write this in another way as follows. All right, and okay, you can write this. You can write it like this. Okay, this is another way to write it. Now we need to show that this is unbiased too. So what we need to find is we need to show that the bias is 0. So that's what I want to show. I want to show that the bias of this, which is the expectation minus the parameter, we need to show that this is 0, right? So this is gonna be so if you take the expectation inside, it's gonna be the expectation of the first guy, which is okay, plus the expectation of the second guy, which is minus sigma squared. Are you with me, guys? So this is what you get. Now what I'm going to do is I'm going to apply a trick that we talked about a long time ago. You may remember this, but if you don't, I'll let you know in a minute. So what I'm going to do is I'm going to multiply the thing outside by sigma squared, and you see what I've done. I have multiplied outside by sigma squared, and inside the square brackets I have divided by sigma squared. And there's a reason I've done this, because you may recall that long time ago, that is before the Easter break, we talked about the chi-square distribution. Now, if the xi and the yi have the normal distribution, then the thing inside the brackets, the round brackets, will have a chi-square distribution. So what I'm saying is that this is the expectation of a chi-squared variable with n-1 degree of freedom. And this is the expectation of a chi-squared variable with m-1 degree of freedom. So this is let me write it down, using C notes on chi-squared. Chi-squared distribution. You see my notes on chi-squared distribution. Right now, that's what I have used. Now, a property of a chi-squared is that the expectation is equal to the degree of freedom. So what you have is the expectation of chi-squared n-1 is n-1, and the expectation of chi-squared m-1 is m-1. All right, and this is clearly equal to 0. So hence we have shown that this estimator is unbiased for sigma squared. Is it clear to you guys or not? Hello guys, talk to me, please. Is this okay with you guys? How I have done part 1 of question 3. Okay, thank you guys. All right, and now part 2. The part 2 of question 3 is asking you to obtain an expression for the variance of mu hat. So I will do that in a sec. Give me a sec. Give me one minute. I will show you how to. Okay, let me show you how to do part 2 of question 3. Okay, so this is part 2. So we want to find an expression for the variance of mu hat, which is equal to the variance of n times x bar plus m times y bar divided by n plus m. Okay. Now, when you take a variance inside the brackets, you need to square all the terms. I'm sure you know that. So this becomes n squared divided by n plus m squared times the variance of x bar plus m squared divided by n plus m squared times the variance of y bar. Okay, you follow me? So this becomes n squared x bar. I'm sure you know x bar is simply 1 over n times the sum of xi. Okay, and m squared divided by n plus m squared times the variance of 1 over 1 divided by m times the sum of y's. Okay, guys, now I'm going to simplify. I'm going to take the variance inside the brackets. So this becomes n squared divided by, if you take the n outside, it becomes 1 over n squared times the sum of the variance of xi. Okay, then plus 1 over m squared times the sum of the variance of y's. All right, so the n squared and the n squared cancel. So what you get is 1 over n plus m squared and times the sum of variance of xi is sigma squared, right? And plus 1 over n plus m squared times the sum of sigma squared, right? So what you get is 1 over n plus m squared times n plus m sigma squared, right? So this is sigma squared divided by n plus m, right? So that's the expression for the variance of mu hat, right? Part 2 of question 3 is asking you. Now, as this clearly goes to 0, as n goes to infinity, and m goes to infinity, right? In fact, it's sufficient if either one of those happens, right? That is, if either n goes to infinity or m goes to infinity, then that variance of mu hat will go to 0, right? All right, guys, are you okay with this? Are you okay, guys, with this or not? So that completes question number 3 of sheet number 10, right? Yeah. So we have complete. It's only it's 10 minutes to 1 o'clock UK time now. So it's so I will do the remaining. There are 3 questions left. I will do the questions from 1 to 2. So I will wait for other people to join in. So I'll wait till 1 o'clock and then I will start doing question number. So let me put this up so that I will give you a 10 minutes break now. I will give you a 10 minutes break now, and then I will start doing, after 10 minutes I will start doing question number 5. So let me show you. Maybe you can have a look at it. All right, can you do question 5 now, please? Question 5. So I will start doing that in 10 minutes time. So please look at question 5 if you have to. Hello guys, you okay? Hi guys, have you done question 5 yet or no? Not yet. Mm. All right, if you haven't done it, okay, let me show you how to do it. So this is question number 5 on sheet number 10. Okay. Give me a sec. Okay. So let me see where it is. Okay, so we are looking at question 5. So you have two different samples. So the question here is about two different proportions. Px denotes the proportion voting voting for presidential election. Election in California. Okay, that's the proportion. That's the first proportion. The second proportion we are interested is in the proportion in Colorado. Okay. So these are the two. And the question here is to find a 95% confidence interval. So the question is to find a 95% confidence interval for the difference in the proportion, that is Px minus Py. Now, if you look at my notes, if you look at my printed notes or the scan notes, you see a formula that I gave you in the class. The formula that I gave you is the following: is x bar is a sample proportion for the first one, the y bar is a sample proportion for the second, plus or minus z. So you will see this N1 is the sample size for the first sample. Okay. So this is the formula that I gave you in the class a long time ago. Thing is before the Easter break, I think. Maybe wrong, I'm wrong. So here all the data is given to you. N1 is the sample size for the first one, which is 288. N2 is the sample size for the second, from the second population, which is 216. Sorry, excuse me. X bar is the sample size, the sample proportion for the first population, which is 141 divided by 288. And Y bar is the sample proportion for the second population, which is 125 divided by 216, right? And alpha is, we are looking for 90%, so alpha is 0.05. Okay, all right, so hence, the 95% CI is as follows. Are you guys okay? All right, the percentile for the from the normal distribution is 1.96, right? I'm sure all of you know. I mean, I showed you a long time ago how to read the normal table. Okay. Then square root x bar is 141 divided by 288. Divided by 288. Y bar is 125 divided by 216. Okay, so this is the 95% confidence interval for the difference in the proportions. Obviously, if you have a calculator, let me check the solution. The solution is online, so you should be able to see it. Let me check what it is. The solution is okay. The solution is as follows. So if you work this out, you will get the lower limit is minus 0.1177, and the upper limit is minus 0.0015. So both limits are negative, right? All right. So in other words, the confidence interval for Px minus Py is less than 0. So we can conclude. So what we can conclude from this is that Px minus Py is almost not equal to 0. So in other words, it certainly must be negative, right? So in other words, the difference in the two proportions the proportion of people voting, the proportion of people voting in California, and minus the proportion of people voting in Colorado is negative, right? Minus, yeah, it's negative. So this is question 5, guys. Are you okay with this or not? Do you have any questions? Hello, guys. Talk to me, please. Are you? So this is the solution to question number 5 from sheet 10. Yeah. Hello, guys. All right. The next question I like you to do, I will give you some time to do it, is the question number 4. Can you do question 4, please? Question number 4. So let me share screen. Here we are. All right. Can you take a few minutes and see if you can do question 4? Are you guys okay? Are you doing question 4, guys, now? Can just please take some time and see if you can do it. Good, good. All right. All right. Let me show you. Let me show you how to do question 4 now. All right. So question 4 is it's like this. Okay, here we are. So question 4. So here we are looking for a confidence interval for the difference in population. So we are looking for a is it 95%? 95% confidence interval for mu1 minus mu2. Excuse me. Sorry, what did I do? Sorry, I pressed some stupid. Don't know what I did. Excuse me. Sorry. Excuse me. Sorry. Excuse me. Just give me 1 second. Just give me 1 second, okay, guys? Just 1 minute. Okay, share. Okay, here we are. We are back on now. All right. I'm sorry for that. Something happened. I don't know what happened. Let me go back to the very bottom of this where I was. So, okay. Okay, here we are. We are looking for a confidence interval for the difference in population. The population means, all right, which is mu1 minus, sorry. We are looking for the mu1 minus mu2. Sorry, what am I doing? All right, so the confidence interval we are looking for is assuming that the common variance, we are assuming that the variance is common but is unknown. So in this case, if you remember from my notes, if you remember from my notes, in this case the formula for the confidence interval is like this. This if you look back in my notes, which I gave before the Easter break, you will see this formula, right? Sorry, by the way, this should be not m plus n, it should be n1 plus n2. So this is n1 N1 plus N2. Okay, so this is the formula for the confidence interval for the difference in two population means, where SP is the sample pooled standard deviation, is given by the square root of N1 minus 1 S1 squared plus N2 minus 1 S2 squared divided by N1 plus N2.
Slide down later this time.
We are given that N1 and you're also given that X bar 1 is equal to 21.8. X bar 2 is equal to 18.9. And you're also told that S1 is the sample standard deviation for the first sample, is 8.7. And you're also told that S2 is equal to 7.5. Okay, so given all this, we can work out. So hence, the 90% confidence interval is as follows. So it's going to be 21.8 minus 18.9 plus or minus T. N1 plus N2 is 24. So it's 24 minus 2. Alpha is 95%. So 1 minus alpha by 2 is 0.975 times SP. I will come back to that later. SP is the sample pooled standard deviation times 1/12 plus 1/12. Okay, so this is the confidence interval where SP, I'll work it out in a minute. SP, excuse me, I don't know why it is. SP is equal to the square root of N1 minus 1, which is 12 minus 1, S1 squared, which is 21.8 squared, sorry, it's not 21. I'm sorry. This S is 8.7 squared. 8.7 squared. Then you have 7.5 squared divided by 12 plus 12 minus 2. So this is the sample pooled standard deviation. Now, if you work this out, you should have a calculator. If you look up the solutions online, you will see that this is equal to 65.97 square root, right? Okay, so this is the pooled standard deviation. Okay, so hence now you should sub this back into this. this guy here will become like this. So it will become 21.8 minus 18.9 plus or minus. If you read this percentile from the T table, which I gave you a long time ago before the Easter break, if you read this, you will see is 2.074. SP is the square root of 65.97. And then you have 1/6 square root. Okay, so this is what you have. And you should simplify this using, if you simplify it, you will get minus 3.98, comma 9.78. So 9.78 rather, 9.7. Okay, so this is the 95% confidence interval for mu1 minus mu2, right? So since this interval, right, since the interval contains 0, it is possible that mu1 could be equal to mu2, right? Remember, if mu1 is equal to mu2, then the difference is, of course, 0, right? So since the interval contains the value 0, it is possible that mu1 is equal to mu2. All right, guys, so this is the solution for question number 4. Any questions? Anything that is not clear, please let me know. All right. Okay, guys. And the only question I haven't done today is, the only question that I have not done is question number 2. So can you look at question 2, please? Question 2. So let me go back to. Can you guys hear me now? Okay. Somebody said they can't hear me. Is it okay now? Okay. I hope you can hear me now. Okay. Thank you, sir. Thank you very much. So share screen. Go back to this share screen. Okay. All right. The only question I haven't done is question number 2. So can you look at this, please? Question number 2, guys. Hello guys, could you work on question two, please? Question two. That's the only question we haven't done today. Hello guys, have you done question two? So let me show you how to do question two if you haven't done it. Okay. So share screen. So there are two parts. I will only do the first part because part two is similar to the question I have already done. So question two, part one. So you have the data, right? And you're asked to find the confidence interval for the difference in the two population means, right? Brand A and brand B. So if you use the, once again, okay, the 95%. if you look at my notes I gave before the Easter break, is as follows. This is the formula that I gave you guys. If you look back in the notes, is plus or minus z sigma x squared divided by m, because in part one we are assuming that the population variances are known and they are not equal. Okay, so this is the formula you need to use, right? So x bar is already given to us. X bar is the sample mean for the first sample, which is 1386. Y bar is 1218. Okay, and sigma x squared is the population variance for the first one. Is 114 squared because 114 is the sample, is the population standard deviation, so you need to square it. And sigma y squared is similarly 98 squared. M is the first sample size, which is 150, and N is 200. So these are all the data that's given to you, all right? And alpha is 95%, so alpha is 0.05. Okay. So given all this data, you should be able to find the confidence, and so hence the 95% CI is as follows, all right? X, so it's 1386 minus 1218 plus or minus. The Z value at 0.975 is 1.96, right? In square root, you have 114 squared divided by M, which is 150, plus 200 squared divided by 200, yeah. Sorry, 98 squared, I'm sorry. This should be 98, not 200. 98 squared divided by 200. All right, so this is the 95% confidence interval for the difference in the population means. Of course, you can simplify it. Let me check the solutions. The solution is this. So you should work this out using a calculator or program. So the 95% confidence interval is from 100. The lower limit is 145.26, and the upper limit is 190.74. Okay. All right. So this is the 95% confidence interval for the difference in the population means, right? All right, guys. Any question? And part two is similar to the question that I have already done. So you should be able to do part two by, excuse me. You should be able to do part two by yourself, right? Okay, guys. So any questions you like to ask me before, because we just we are approaching 2 o'clock UK time. I don't know what time in China is now. Yeah, it's approaching 2 o'clock here. So tomorrow is Friday. Tomorrow we have an example class from 1 to 2. So sorry, 11 to noon. We have an example class tomorrow from 11 to noon. If you like, you can come to that too. Otherwise, I hope I wish you that you have a good day today, wherever you are. So, any questions you have about quiz 10 or anything? Quiz 10 is due next Tuesday, but I would appreciate if you could hand it in on Monday or before that. So, if you have any questions on quiz 10 or any other questions related to the course, please email me 24/7 or Zoom me 24/7. Okay, guys. Otherwise, I wish you have a good day and a good weekend, right?
Okay, thank you, sir. Thank you so much.
Yeah, my pleasure. My pleasure.
Yeah. Okay, see you tomorrow.
See you guys.